Welcome to BMAC.MATH tutorial. Subscribe to our channel for freshly uploaded content. This is a question from CSI NET 2019 December session. We are given a monotonic function f which satisfies the condition f of 1/4 f of 3/4 is less than 0, which means that f of 1/4 and f of 3/4 have opposite signs. Also, let us denote the set A as the set of all points in closed interval 0, 1 such that f of x is strictly less than 0. We are given that supremum of A is equals to alpha. This is a question from section C. We will check the validity of each of the conditions one by one. Let us start with option 4. Let f be decreasing. So, since f of 1/4 and f of 3/4 have opposite signs, so this means that f of 1/4 has to be greater than 0 and f of 3/4 has to be less than 0. Thus 3/4 belongs to the set A, and since alpha is the supremum of A, 3/4 is less equals to alpha. Since f is decreasing, so f of alpha must be less than 0. Thus option 4 is correct. For option 3, we are given that f is continuous and 1/4 less alpha less 3/4. Since f is continuous and f of 3/4 and 1/4 have opposite signs, so by intermediate value theorem we can say that there exists some point alpha naught in 1/4, 3/4 such that f of alpha naught is equals to 0. Since alpha is the supremum of A, so we must have alpha is less equals to alpha naught. We consider two cases when f is monotonically increasing and when f is monotonically decreasing. Let us first assume that f is monotonically increasing. So since alpha is less equals to alpha naught, this implies f of alpha is less equals to f of alpha naught, which is 0, or f of alpha is less equals to 0. If we show that f of alpha can't be less than 0, so if possible let f of alpha is strictly less than 0. Now since f is continuous, so f is also continuous at alpha, and thus there exists a neighborhood, say alpha minus epsilon, alpha plus epsilon for some epsilon strictly greater than 0, such that f of x is strictly less than 0 for all x belongs to alpha minus epsilon, alpha plus epsilon. But this violates the fact that alpha is the supremum of the set A. Thus f of alpha can't be less than 0, and hence f of alpha is equals to 0. Thus the option 3 is true if f is monotonically increasing. We can similarly show that f of alpha is 0, or option 3 is true if f is monotonically decreasing. We can show that f of alpha is 0 if f is monotonically decreasing. Thus option 3 is correct. For option 2, we are given that if f is increasing, then f of alpha is strictly or less or equals to 0. Let us consider an example. F of x is equals to 1 when x belongs to minus 1, and f of x equals to 1 when x belongs to half 1. We see that f is increasing number 1. F of 1/4 is -1, f of 3/4 is 1, and f of 1/4 into f of 3/4 is equals to -1 into 1, -1 less than 0. Thus this f satisfies all the conditions given in the problem, and also the set A is the set of all x in 0, 1 such that f of x is strictly less than 0. This is none other than the set closed 0, open half, and supremum of A is half. Also, f of half, as we have seen, is 1, and that is strictly greater than 0. Thus 2 is false. And similarly, using this particular f, we can say that option 1 is also false. Thus 3 and 4 are our correct options.